Okay, in this lesson I'm going to just revise 4 theorems again from Junior Cert, theorems 2, 6, 14 and 15. Theorem 2 was my isosceles triangle theorem. You can pause the video and read through it. Theorem 6 is my exterior angles theorem. Theorem 14 and 15 is the theorem of Pythagoras. So theorem 2 is my isosceles triangles theorem. Theorem 6 is my exterior angles theorem. And theorem 14 and 15, they relate to Pythagoras, the theorem of Pythagoras. Okay, so have a read through those, and we're going to look at examples where I'm going to use each one of these things. So theorem 2 says in an isosceles triangle the angles opposite the equal sides are equal. So given this first triangle, notice the tick marks here. These are called tick marks, and they're telling me we have equal sides. What theorem 2, the isosceles triangle theorem, says is the angles opposite those sides must be equal. So this angle opposite this must be equal to this angle opposite this. That has to be 70 degrees. Note also that means we can find that missing angle up there because of the triangle sum theorem, which says 3 angles in a triangle have to sum to 180. Conversely, if 2 angles are equal, then the triangle is isosceles. So we've got the pair of equal angles in here. That means the triangle is isosceles. Notice that's got to be a right angle because of the triangle sum theorem, which says 3 internal angles have to add to 180. The sides opposite those equal angles are equal, so I'm putting in tick marks to demonstrate that. That's theorem 2. Theorem 6 says each exterior angle of a triangle is equal to the sum of the interior opposite angles. And when we have a triangle, you know, every triangle has 6 exterior angles. There's one. Okay? But there's another. And an exterior angle is made by extending the side out and just connecting that up to there. And at every vertex, there are 2 exterior angles. Okay? They're what we call exterior angles. So this exterior angles theorem says the exterior angle is equal to the sum of the 2 opposite interior angles. Notice that would have to be equal to 30 plus 45, 75. That's what theorem 6 says. Also note the triangle angle sum theorem says 3 angles inside a triangle have to add to 180. That would mean that would have to be 105. Notice they're a linear pair as well, adding to 180. Here we're given the exterior angle and one of the interior opposite angles. This number has to be the number I add to 85 to get to 130, and I think that's going to be 45 degrees. So I can fill in my 45 degree there because together 85 and 45 make 130, and each exterior angle is equal to the sum of the interior opposite angles. Notice these two form a linear pair, so that has to be 50. Notice 50 added to 85, 135 added to 45, 180. Theorem 14 and 15 is the theorem of Pythagoras. So each row contains the side lengths of a triangle ABC, which is right angled at C. Notice capital letters for angles, so we're talking about triangle ABC, which is right angled at C. That means that side is little c. Remember, we always name the side opposite the angle, we give them the same name. So if we call that A and that B, well, that will be little a, that will be little b. Theorem 14 and 15 together, they kind of say triangle ABC is right angled at C if and only if a squared plus b squared equals c squared. So 3 squared plus 4 squared would have to be equal to what number squared? You can work out that that's 5. Each row contains the side lengths of a triangle ABC, which is right angled at C. So C is the hypotenuse here. Three squared plus 4 squared is 5 squared. Something squared plus 12 squared is 13 squared. You can work this out. Yeah, you know, we're going to talk about a squared plus 12 squared equals 13 squared. If you solve that equation, you're going to find that a is equal to 5. If you solve this equation, 7 squared plus b squared equals 25 squared, you're going to find that's 24. 8 squared plus 15 squared you're going to find that's 17 squared. 9 squared plus something squared equals 41 squared, and that's 40. Okay. How do I know these things? Well, I know all of these because they're all Pythagorean triples, which we've looked at before. And the reason they're Pythagorean triples is they are all sets of integers, 3 integers, which satisfy the Pythagorean equation. Okay, they all satisfy the Pythagorean equation. Notice that's the Pythagorean equation, but this is the Pythagorean theorem. Okay, the equation is just a part of that. Which of the following are the side lengths of a right triangle? Well, in order for them to be a side lengths of a right triangle, a squared plus b squared has to be c squared, where c is the longest side. So 30 squared plus 40 squared is equal to 50 squared, and you can check that. So this is a right triangle. These are side lengths in a right triangle. If I look at the next one, you look at 7 squared and add it to 15 squared, you will find that is not equal to 18 squared. So this is not the side lengths of a right triangle. You will find that's the side lengths of a right triangle because if I square root 2 and add it to the square of root 2, I will get the square of 2. And again, you might recognize those as being the ratios of the side lengths in a 45, 45, 90. Again, I'm hoping you recognize one is root 3 is to 2. This side lengths in a 30, 60, 90. So you'll find that is, you'll find that is not, you will find that is. Okay, so that's the Pythagorean theorem. You've got to be used to it. Okay, so practice those things. We're in section 6.1 in your textbook.